All right, so welcome to tonight's lesson. So in this lesson, like I said, we're just going to have a tutorial where I'll just go through some questions under what we have covered so far. All right, so let's quickly begin. So in case you have any questions or you want to join the lessons that I teach online for mathematics and physics, you can simply just use these lines on the screen. On WhatsApp, you can use the first line and the second line to contact me. And then in case you want to send an email, you can also use this line. So in case you also have other questions that you would want to ask in physics and mathematics, even chemistry, you can also contact me using these contacts. All right, so let's quickly begin. So our first question here is a very simple question, and it's under sets. It says if A is equal to 1, 2, 3, 4, and B is equal to 3, 4, 5, and C is equal to 4, 5, 7, 8, find A intersection B. And then B says we find B intersection C, and then C said we find the difference, the set difference of B and C. All right, so these are very simple questions. Like I said, let's see how we can solve them. So, okay. Okay, so the first question is, we've been asked to find A intersection B. So how do we find this? So the first thing that you need to look at are the sets that you've been given. And you also have to understand the symbol intersection. What does it mean? So whenever you see this symbol, it simply means that you have to look for common elements in the sets that have been mentioned in the question. So in this case, we have set A and set B. So we need to look for the common elements in set A and B, and then we put them together. But as you are looking at, okay, I'll explain this when we start looking at union. Yeah, so we first have to look at the common elements that are in A and B, and then we put them in a set. Okay, so open the brackets. So let's try, let's look at the elements that are common. So when you check set A, so in set A, we have elements 1, 2, 3, and 4. These are the elements that we have in set A. And then in set B, we have elements 3, 4, and 5. So now we have to look at the common elements. So the common elements are the ones that we're going to put in A intersection B. So let's check the sets. So as we can see, we have 1 there. We don't have 1 in this set. We have 2 there. We don't have 2 in this set. We have 3 there. We also have 3 there. We have 4 there. We also have 4 there. So the common elements that we have are 3 and 4. So these are the 2 elements that we have, which are common in set A and set B. And hence, this is the intersection. So if they ask you to find the intersection of 2 sets, they are simply asking you to find the common elements that are in those 2 sets. Let's quickly move on to B. So part B is asking us to find B intersection C. So B intersection C, let me also list set C here. So set C is simply just 4, 5, 7, and 8. So we're still looking at the intersection. So whenever you've been asked to find the intersection set of 2 sets, they're simply asking you to look for the common elements in those given sets. So let's look at what is common between set B and set C. So we're checking this set here and that set. Okay, so we look at the common elements. We have 3 there. We don't have 3 in this set. We have 4 there. We have 4 there. So one of the common elements that we have is 4. And then we also have 5 there, and then there's also 5 there. So 5 is also common. So this is, B intersection C. So this is the set, or rather this is the solution to part B. So let's look at part C, which is the last question on the first one there. So when they ask you to list B intersection C, they simply mean you list the elements that are in B, excluding those that are in C. Yeah, so B minus C simply means you list the elements that are in B, excluding those that are in C. That's what it means. And the mathematical way you can represent this is simply just equal to B intersection C complement. Whenever we talk about a complement, if we say A complement, we are simply talking about you listing the elements that are not in A. So for instance, if I say A complement means that we list the elements that are in the, universal set, excluding those that are in A. That's what it means. So if they say B intersection C complement, it means that we're going to look at the elements that are in B and also the elements that are not in C, but they are in the universal set, and then we list them. We list the common ones because we're dealing with intersection. So in this case, since we have not been given the universal set, this might be a bit tricky to use. And hence we just go by knowing that B minus C is simply listing the elements that are in B, excluding those that are in C. So B minus C is simply just equal to, so we list the elements that are in B, but we have to exclude those that are common. Okay, so let's look at the sets B and C. So we have B there, and we also have C. So we look at the elements that are in B. So we can list the elements that are in B. There's somebody who's trying to write on the board. Please look at your phone properly. Okay. So we have B minus C. So we list the elements that are in B. In B, we have 3, 4, and 5. So in other words, we're going to list the elements that are in B, excluding those that are in C. So the other way I can explain this is we list the elements that are in B, excluding the intersection set between B and C. So the intersection set between B and C is simply just 4 and 5. So we're going to list C excluding this set. So we are, that means we're just going to have 3 as our element in B minus C, because we know that 4 and 5 are part of set C as well. So we're not supposed to list those. And a set that contains only one element is called a singleton set. So this is a singleton set. All right, so we quickly move on to part B, rather the second part of this question. Before we can move on, do you have any questions on the first question, on the first part of the question? If anyone has a question, they can just unmute themselves and ask. Okay, so
a misunderstanding. Can you kindly explain what you said again about the complement thing, like the C complement? Kindly say what you said again about a set that's complement.
okay, so I was saying, if we say a complement, if for instance we say a complement, it means that you have to list the elements that are in the universal set, but they are not in A. So if you have not been given the universal set and they ask you to list a complement, it becomes tricky that way. I think it's not even possible. So the only way they can, the only time when they can ask you to list a complement or the complement of any set, there has to be a universal set somewhere, so that you list the elements that are in the universal set, and then you just exclude the elements that are in A. That's what it means when you talk about a complement. So if we say C complement, it means that we are listing the elements that are outside C. That's the simplest definition. Yeah, but I said this one, yes, this one can't be used because we don't have the universal set. And hence we just use the definition of B minus C, which means that we're listing the elements that are in B, excluding those that are in C. Okay, so we move on to the second.
All right, thank you.
You're most welcome. All right, so we move on to the second question. The second question there, we've been given the universal set, which is 1, 2, 3, 4, 5, 6, 7, 8, 9. And then set A is 1, 2, 3, 4. Set B is 2, 4, 6, 8. Set C is 3, 4, 5, 6. And then they're asking us to find A intersection C complement. So whenever you've been asked to find this, if you want, you can first use De Morgan's rule, where you distribute the complement and the sign in between will change. So you're going to distribute the complement, we're going to have A complement, and then union, the sign in between is going to change. Hence you have union, and then C complement as well. So having done this, you can now find A complement and C complement. Then when you find A complement and C complement, then you find the union set. Union means you are adding two sets. But as you are adding those two sets, you have to make sure that you list those numbers that are repeating once. You don't have to list them two times. Yeah, so this was just the other way you can solve the first question there. So the best way you can solve this one is just by following BODMAS, meaning you start with what is in the brackets. So we have A intersection C complement. So I'll first find what is in the brackets. So what is in the brackets there? We have A intersection C. So this is what we have in the brackets. So I'll first find A intersection C, meaning I'll find the common elements between A and C. So in A we have 1, 2, 3, 4. And then in C we have 3, 4, 5, 6. So the common elements between A and C are simply, so the common elements, we have 3 there, we also have 3 there. We have 4 there, we also have 4 there. So the common elements between the common elements between set B and C, sorry, was I looking at B and C? Okay, A and C are simply just 3 and 4. These are the common elements. Now, when we talk about A intersection C complement, meaning we're going to list the other elements that are remaining in the universal set, excluding these that are in the intersection there. So A intersection, okay, let me just say this is equal to, so that we can leave space to solve other questions. So A intersection C complement is therefore equal to, so we list the other remaining elements in the universal set, which is U there. So in the universal set, we have 1, we have 2, then we have 3 there in the intersection, but we are looking for the complement of this intersection, meaning we list anything that is in the universal set, excluding what is in the intersection. So we're going to skip 3 and 4. So we move to 5, then we have 6, 7, 8, and 9. So this is our A intersection C complement. So let us also find B intersection C complement. So B intersection C complement is also very simple. How do we find that? So first of all, we find what is in the brackets, which is B intersection C. So B intersection C is therefore equal to the common elements between B and C. So we look at B and C and then we identify what is common. So let's look at what is common between B and C. So in B there we have, so what is common there? We have 4 there. We also have 4 in C. Then we have 6 there. We also have 6 in C. So the common elements between B and C are simply 4 and 6. So these are the 2 common elements. Now to find B intersection C complement, meaning we're trying to find the complement of this set here. Hence, we're going to look at the universal set and list everything that is in the universal set, excluding what is in B intersection C. So we are going to have 1, 2, 3, then we skip 4 and 6. So we write 5, then we skip 6 there as well. So I'm going to write 7, 8, 9. So these this is what we have as our B intersection C complement. Okay, so now let us quickly look at A minus C complement. So A minus C complement. Okay, so for A minus C complement, even this one, if you want, you can first deal with it using De Morgan's. So before we use De Morgan's, we can change A minus C. Remember, I said if you have A minus B, this can also be written as A intersection B complement. So you can write this as A intersection C complement. Then from there, there's this complement there, you write it there. Simplifying this further is going to result to, we distribute the complement. So we're going to have A complement there. We have A complement, and then the sign there will change. So this is going to be union. Then you have C complement there. But because there's also another complement there, if it joins with that complement, the complement disappears. So we're going to have A complement union C. So after doing this, you can now find A complement. So A complement is therefore going to be equal to, we list all the elements that are in the universal set, excluding those that are in A. So the universal set there we have, in A we have 1, 2, 3, 4. So meaning our A complement will start from 5, then we have 6, 7, 8, and 9. So this is our A complement. So now we have to also list set C. So set C is therefore equal to, set C has been given to be 3, 4, 5, 6. And this is our set C. So we have to combine, since there's a union set, there's a union symbol there, we have to combine the 2 sets. So our A complement union C. So addition of 2 sets, we combine them, but making sure that we don't repeat the common elements. So 5 and 6 are common. So I'm just going to write them once. So the universal set, or rather the the union set, will therefore be 3. We have 3 there, we have 4. We have 5, 6. Then we have 7, 8, 9. So this is the solution. So if you don't want to use De Morgan's, you can first find what A minus C is, and then after finding A minus C, you now have to find the complement of your answer that you get. So A minus C simply just listing the elements that are in A, excluding those that are in C. So listing such elements, it means that we're going to have what? We're going to have 1. And then apart from that, we're listing A, excluding those that are in C. So if we list A, excluding those that are in C, we're going to have 1, then we're going to have 2. So we can't list 3 and 4 because they are in C. So we just end there. So now to find the complement of this set, so the complement of A minus C is simply equal to meaning we're going to list all the elements that are in the universal set, excluding those that are in this set. So meaning we're just going to list everything starting from 3. So we have 3, 4, 5, 6, 7, 8, 9. So this is the set. As you can see, we have found the same answer. Yeah, so we move on to the next question. Or before I can proceed, do you have any questions before we move on to the next question? Okay, so we proceed.